All right, let's look at these other two piecewise function type problems, type problem 2 and 3. So if you look at this piecewise function, this one is divided at -1. So left of -1, it's going to be this equation, which is a line. And on the right of -1, it's going to be this line. So if I think about it, so we'll have left of -1, and then we'll have right of -1, bigger and smaller. So if you think of left of -1, that's when we're going to have -x plus 3. And right of -1, we're going to have -3x plus 1. So for both of these, I want to go ahead and I want to make little tables for them. Now again, this one's for x less than -1. This is for x greater than or equal to -1. So I really just took my function and I split it into two parts. So when I do my tables, I want to make sure I pick x's that are less than -1. So I'll pick -1, -2, and -3. Now I know -1 is not really less than -1, it's equal, but I'm going to put it anyways. And remember, you can still use it, it's just going to be the open circle. Because you want to go all the way to -1, but just not to -1. That's why we use the open circle. So I'll just plug these x's into my function. So I'll get -1 plus 3, which is 4, -2 plus 3, which is 5, -3 plus 3, which is 6. So I'll have these points -1, 4, which again I'm going to make an open circle because remember, it can't get to -1, but it can get really, really, really close. And here are my other points. So this is my portion of the line. Now I don't have anything to the right of -1 because this part is only defined for x's less than -1. So I'll do the same thing for the second one, and the second line could connect. It could connect at this point or it could not. It doesn't really, it's not predetermined. So I'll do -1 again. In this case, it's going to be a closed circle, though, because in this case, x can be -1. And then I'll do 0 and 1. I'm just picking numbers bigger than or equal to -1. So I'm going to put these numbers into this function. So -3 times -1 is 3, plus 1 is 4. -3 times 0 is 0, plus 1 is 1. And if I go to 1, -3 times 1 is -2, plus 1 is -1. So when I do the second part in this case, you'll notice -1, 4 actually is at the same spot as that open circle. And then we have 0, 1, and we have 1, -1. So this line, I'm sorry, this is -2. I misspoke. So -2, so that's down there. I knew that didn't look quite right. So that one looks like this. So I just pick some numbers in that domain, get my two pieces. In this case, since they connect, they did connect, this would be continuous. If they didn't connect, then we would say it's not. So this one is this other kind of problem. This is a type 3 problem. It's really kind of the same thing, except for you notice that the first part is between -4 and 4, and the other one is just x greater than 4. So I have my left. My left is this kind of parabola part where I'm only picking x's that are between -4 and 4, including -4, but not including 4. And then my right side, I'm going to have x's that are bigger than or equal to 4. And I kind of know just from what it looks like, this part's going to be a line, and this part is going to be a parabola, some kind of squaring function. So when I make my charts, when I pick my x's, since this one doesn't go down forever, -4 is pretty much the smallest it's going to be. I definitely want to pick -4. And I definitely want to pick 4 because that's the boundary. Now that 4 will be open because it's strictly less than 4, but I want to have it open. And then maybe I just pick a couple points in between. How about 0 and 1? Those are just arbitrary points I'm picking. Now when I plug these in, again, I'll plug these into my function, which is -x squared plus 10. So if I do negative 4 squared, I get 16, plus the negative is negative 16, plus 10 is negative 6. 0 will be 10. 1 will be negative 1 plus 10, which is 9. And then 4, again, will be 16, negative sign makes it negative 16, plus 10 is negative 6. So if I just try to make a little sketch of this graph, Alex will definitely give you a graph to do this on. I don't have one. So it goes pretty high and pretty low, so I'm going to go by 2. So negative 2, negative 4, negative 6, 2, 4, 6, 8, 10. And then I have 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3, 4, 5, 6, 7, 8. So I just went by 1s on the x-axis, and I went by 2s on the y-axis. You could make them all 2s or all 1s, it doesn't matter. Alex will probably make them all the same. But anyways, I'll go negative 4, negative 6, and negative 4, negative 6 is down here, and it's going to be a closed circle. The next point I have is 0, 10, which is way up here. 1, 9 is going to be just slightly smaller, and then 4, negative 6 is going to be an open circle, because remember, it's less than 4, not equal to. So that looks something like this. Now, you don't have to see, this is a really nice one where you see most of the parabola. It doesn't have to be like that. You could just see half the parabola, or it really just depends. Now for the line part, I'm just going to pick some values bigger or equal to 4, 4, 5, 6, and I'll just plug those in. So negative 4 minus 4 is negative 9. Negative 5 minus 5 is negative 10, and then negative 11. So I'm going to make my graph go down a little bit more. Negative 8, here's negative 10. So if I go 4, negative 9, so in this case, 4, negative 9, unlike the last one, it doesn't connect. And then 5, negative 10 will be down here. And then my final one, 6, negative 11, will be a little lower. And that's just a line, so it's going to look like this. So this one, since there is this gap, they don't connect, this is not continuous. Because that idea of continuous, remember, if I'm tracing this with my pencil or whatever, I don't have to lift my pencil off the page, but here I obviously would to go down here. So those are the last two topics, so let me know if you have questions on those.